On July 1965, almost 60 years ago, the Mariner 4 spacecraft sent back these images, the first close-up shots of another planet ever taken from space.
One pass, a single chance for everything to work.
That planet was Mars, and these fuzzy images made this distant object, millions of miles away, feel close enough to touch. Today, breathtaking images like these from NASA's Curiosity rover make it easy to imagine being on the red planet's surface. I can plan my expedition across the Martian desert as easily as a hike on Earth. And as we've traversed across the planet, we've discovered incredible wonders. A labyrinth of deep, steep valleys, a canyon almost 10 times longer and 5 times deeper than our own Grand Canyon, spectacular craters, including one of the largest in the solar system, desert sand whipped up to form monster dust devils, and we're even getting closer and closer to the question of life on Mars. Just last month, Curiosity was reported to have found the longest organic compounds ever found on Mars. The ingredients for life might be right there, just beneath the surface, and there's so much more to be discovered. Tonight, we're uncovering the secrets of the red planet. Welcome to The Sky at Night.
Walking about this amazing environment with its lush vegetation and free-flowing water, it's hard to imagine that Mars was ever like this. Mars is our neighbour, 4th planet out from the Sun, smaller than Earth, about half the diameter. And on Mars, you experience 38% of the gravity we get here on Earth, which sounds like a lot of fun to me. It's an alien world. But one of the things we're realising is, the more we find out about it, the more we realise we have a shared history. Mars was once covered in water, just like Earth, and had a core so active, it created the largest volcano in our solar system, Olympus Mons. All that activity died out billions of years ago, leaving a planet that appears dry and barren. But hidden in those rocks are the answers to secrets, not just about Mars, but about other planets, including our own. Secrets about climate change, planetary evolution, and even how life began. Over the decades, helped by some of the toughest space explorers in the solar system, we've been unlocking some of these answers. Chris is in London to find out what we've been discovering.
In 1976, the Viking 1 lander touched down on the Martian surface, providing us with our first clear images from the planet. Technology since then has moved on in leaps and bounds, thanks particularly to my favourite amongst our fleet of planetary spacecraft, the Mars rovers. Perseverance is the newest addition to the fleet. Landing on Mars back in 2021. Is equipped with an array of instruments, including several cameras capable of sending back images that transport you to the surface. I'm meeting geologist Sanjeev Gupta, a member of the team running the rover, to take a trip across the red planet. Sanjeev, this is astonishing. I feel like I'm actually on Mars.
We kind of are. These are images from the Perseverance rover in Jezero Crater.
What was it like seeing this landscape for the first time?
Sort of kind of surreal and extraordinary because it actually looks like an Earth-like landscape. We could be in the desert in Nevada, Utah, and yet we're on Mars, hundreds of millions of miles away. It's really quite weird.
Situated in Mars's northern hemisphere, Jezero Crater was formed when an asteroid struck the surface of Mars about 4 billion years ago. The early images sent back by the rover showed a rock-strewn landscape containing clues of what early Mars must have been like. So, You're the geologist. Tell me what you see when we look around this site.
Oh, so this panorama was taken early on after we landed, and this is sort of within the crater, and we're looking out towards the west, and we can see we're actually stood on rocks that we actually had no idea what they were before we landed.
So what did these white rocks, these light rocks, turn out to be?
So we argued about it for ages, and then it's when we applied some of our detailed chemistry instruments that we were able to work out that these are actually volcanic rocks.
And what was the giveaway? What was the kind of evidence that you got?
So we could actually map in detail the grains, in particular grains of a mineral called olivine, and it was very, very clearly of volcanic origin.
It's volcanic rocks like these that could one day tell us about the inner workings of Mars. But the landscape itself also has clues that tell us how this part of Mars once looked.
So the gap you can see there in the mountainside, that's actually a former river valley, with the river coming from outside the crater, entering the crater and building a lake within the crater.
How long would it have taken for something like that to form?
What we do know by looking closely at these rocks, the sedimentary rocks that form the delta, is that it requires sustained water. Most of the delta rocks appear to suggest that there were regular, continuous river flows building this delta. So I think that's quite a big finding, actually. Sustained water 3.7 billion years ago on Mars. It was a watery, wet place.
Once we know water flowed across this surface, it's easy to think of ancient Mars as a bit Earth-like. About a year after landing, the rover had moved on to the foot of the delta, where the water flowed in, and it was the rocks seen in this natural colour image that provided a more detailed picture of how this ancient water flowed.
What's very exciting is these light-coloured rocks that you can see here. You can see they're really flaky. They're really, really thin, breaking up. And these are mudstones. These are really, really fine-grained rocks. And they've really formed by very fine particles settling out of suspension in a standing body of water in a lake deposit.
So that's one of the reasons we know it was a standing body of water. It was a lake. It wasn't just water that flooded over the landscape.
Exactly. This required a quiet water environment, so there was water standing there for tens, hundreds, maybe thousands of years. And they're really good places to search for evidence for life, because this is a quiet water environment where life is likely to have evolved in.
The picture we're getting is of the kind of watery conditions where life could have evolved. But to find out if it did, we need a closer look at those rocks. And so Perseverance has been collecting samples in the hope that one day they'll be returned to Earth for analysis. In the meantime, the rover has moved on, and having travelled about 20 miles since it landed, it's reached the crater's edge, sending back this wonderful image just a few months ago. Wow, this is just beautiful. Where are we?
So we're on the crater rim, and this is an enhanced colour image to bring out these beautiful details, all the different colours of the rocks and the different varieties of rocks.
And what are the rocks like up here? Are they the same as in the delta?
Oh no, they're completely different. This is the ancient, what we call the basement rocks, the oldest rocks that the crater was formed in. So the rocks that you can see here on the rim was what the asteroid or meteorite impacted into, deformed and formed the crater, and these are now preserved here.
And these are very old.
These are very, very old. So these are like 3.9 billion years old, something like that. And we have really no idea what they are, and we're just trying to reconstruct that at the moment.
And the nice thing, I think, is that this landscape is older than anything we have on Earth.
That's right, yeah. Some of these rocks, and if you look beyond in the distance, those rocks, those are older than anything we really have. And so really get the deep understanding of the early history of rocky planets here.
In this beautiful place. Thank you so much for showing us it.
Pleasure.
Our existing rovers are building up our understanding of the red planet's past. But soon, future missions could do even more. Maybe even answer the ultimate secret. Was there life on Mars? ESA's ExoMars project is hoping to answer just that. The mission includes the UK-built Rosalind Franklin rover, due to launch in 2028. It's equipped with next-generation instrumentation, and it's on the hunt for well-preserved organic biomarkers hidden beneath the surface. But it's rocks much closer to home that are helping it prepare for its mission. Maggie's headed north to find out.
Exposed slabs of rock found all over Scotland were formed millions, if not billions of years ago. Layer upon layer of sediment and dead material compacted together, trapping evidence of early life. But the question is, could the same be found on Mars? To find out what rocks on Mars could reveal about possible former life on the planet, we first need to understand where to look here on Earth. And so a team of scientists are analysing samples from the northwest of Scotland to reveal the chemical signatures of ancient life. I'm joining Claire Cousins of the University of St Andrews to find out more. So Claire, you've been collecting samples. Can you tell me more about them?
Yes, absolutely, Maggie. So we've been looking at some rocks in the northwest of Scotland. So this is one of them here. And these rocks are amazing because they're about 1 billion years old, but they're incredibly pristine.
So can you talk me through the rock?
Yeah, absolutely. So if you look really carefully just at the very surface, you can see this kind of spiderweb sort of structure. This is left behind by microorganisms that were living their best lives, kind of left behind this beautiful sort of network of sort of trace structures in this rock.
And it's by analysing the rocks using an electron microscope that the geochemical signature of this previous life can be found.
This rock was made from muds, these really fine-grained sediments in this wet environment. And these are all just laying down, they produce these really beautiful layers.
Actually, but you can see the sort of striations, the layers are very distinct.
Yes, absolutely. And it's those very layers which actually then trap and capture that microbial material. So every time you get new sediment being washed into the environment, it's then trapping those microorganisms.
And so what's this telling us?
So this is telling us that we have localized elevation of potassium. So where you see all these sort of red kind of blotchy areas, that's where we have locally high potassium levels trapped here within the rocks. Potassium is really interesting because it's sort of locally scavenged by the action of microorganisms.
Around 3.5 to 4 billion years ago, both Earth and Mars had similar climates, with plenty of liquid water. This is also the sort of time when life first started here on Earth. If life also started out on Mars and left behind similar chemical indicators in the rocks, then it's hoped that the ExoMars Rosalind Franklin rover will discover it.
The really unique thing about ExoMars compared to other rovers is that it can get samples from about 2 meters down into the subsurface. The instrument that this is tying into, it's called ENFIS. ENFIS means rainbow in Welsh. It's a Welsh-led instrument, and it's an infrared spectrometer. So that means it looks at the wavelengths of light in the infrared that are bouncing off the rocks that we're exploring. So this is one of the few instruments that actually will analyze the rocks before the rover is drilling. So this helps us then target those rocks and say, this is where we should do, the incredibly time-intensive task of actually drilling into the Martian surface. And it's going to be a completely different picture down there because it's going to be samples of rocks which have not been affected by the surface environment of Mars, which is a very high radiation environment. It's destroyed a lot of organic matter, for example.
So I have to ask a question. Do you think we'll find life on Mars?
It's a really tricky question.
Of life, yes.
There's probably not life on Mars today. But certainly in Mars's past, all the geological evidence on the surface of Mars really shows us that actually in the sort of first billion years, it really wasn't so different to Earth's environment. And of course, we know that life arose here on Earth, this is why we're here today. And so the real big question is whether or not this also happened on Mars. And of course, if it didn't, that's also an interesting question as well. Why didn't it? And that makes us actually really special. And I think it's not something that's going to be achieved with just one particular mission.
Well, thank you. It's fascinating. I'm excited to find out what future rovers will reveal. But in all our Mars explorations so far, no spacecraft has ever made a return trip from the Red Planet. And the time and the cost of spaceflight is one of the major hurdles. But imagine how much more we could discover if we could bring Mars samples back to Earth. Guest presenter Dr. Meki Desi is at Bletchley to find out about an exciting new approach that could one day help make that a reality.
Since the first rockets were launched almost 100 years ago, the fundamentals have actually changed very little. Sure, there have been some improvements in efficiency and in fuel type, but chemical liquid fuel remains one of the most widely used methods of propulsion.
And here we go.
These traditional engines are still the only way to get a spacecraft past Earth's gravity and atmosphere. But attempts are being made to truly revolutionise space travel. Some are looking at solar sails, others at theoretical warp drives, and one UK company is going nuclear. I'm meeting James Lambert from Pulsar Fusion to find out more. Starting with the electric plasma engines they are already building.
Wow. So what do we have here?
So this is one of our electric propulsion engines, and it works by taking an inert gas and using an electric current to push it out of the engine. That's how we get these really high exhaust velocities.
Amazing. I love the design. I feel like if I had one on each hand, I could be like Iron Man.
Exactly like Iron Man, yeah.
And are there different sizes? Is this the only one?
So this is one of our 500 watt engines, quite small, but we also have, over here, a 5 kilowatt engine, much larger, but really just a scaled up version of what I was just holding in my hands.
Engines like these are commonly used for satellites and even small spacecraft. But it's by turning the electric plasma engine nuclear that they hope to change the future.
The goal is to build our Sunbird project, and this is all about maintaining these really high efficiencies, but increasing the thrust of the engine so that you can fly more ambitious projects. So I'm talking about interplanetary missions out to the outer planets or big science missions.
So what kind of propulsion is that?
So this is our fusion propulsion concept. It uses nuclear fusion to actually drive a plasma out of the back of the spacecraft, and that's its source of propulsion.
So what are the fuel savings between using traditional chemical liquid rockets versus nuclear fusion?
Right, it's a huge trade-off. Because the fusion engine is so much more efficient, it's anything from 100 to 1,000 times more effective. So we can carry 100 to 1,000 times less fuel.
The concept that they are developing would see a bank of engines docked in space. Fueled by nuclear fusion, they will then connect with a launch spacecraft and power it through the solar system at high speeds.
So at the moment, with our traditional methods, we're looking at a round trip to Mars for about 2 to 3 years. But with this, you're saying?
Down to a year or better.
Amazing.
Yeah.
So this kind of technology could help us make bringing sample returns back from Mars a reality, and hopefully eventually getting humans to Mars a reality.
Absolutely the works. Putting a new space station in orbit around Mars suddenly becomes much easier as well.
What stage is it currently at?
So at the moment, we're deeply embedded in all of the computer simulation of the reactor and how it would work. The next step is all about building the chamber to actually test it in.
That is so exciting. Good luck, guys.
Thank you, Mackie.
It's early days for the Sunbird project, but it's big dreams like these that could change the way we travel through space. Until then, we continue to observe from a distance, but that doesn't stop big discoveries being made. One of the biggest mysteries of Mars is its water, which once flowed over the planet, but today it's barren and dry. And yet, there are things moving on the surface of Mars, just as we'd expect if water were present. Maggie's in Scotland meeting planetary geologist Lonika Roelofs, who has been trying to solve part of this puzzle.
Lonika, lovely to meet you. Now, we talk about water on Mars, because when we look at Mars today, it is dry, it is barren, it is red, very unlike this. But I guess we believe that there used to be water flowing on the Martian surface.
Yeah, so we have quite a lot of evidence for that, both from minerals that we observe, but also actually from landforms. And I can show you an example if you want. This is a river delta somewhere on Earth, and this is a similar river delta, but then fossilized on the Martian surface.
So I guess this gives us the evidence that there was water on Mars. Where's it gone?
Yeah, so that's actually a big mystery. So part of the water on Mars is still present in its ice caps. So Mars has polar caps. Part of it is as ice in the ground, And very, very deep underground, there might be a trickle of liquid water left, but there's no liquid water on the surface anymore.
While a fraction of the water may still remain on Mars, the vast majority was lost to space. And yet something very eerie has been spotted happening on the Martian surface.
So from afar, Mars seems like a cold desert right now. But if we zoom in, we actually see movement of material on the surface. Now I have an example for you here.
Yes.
So this is a channel system on a hill slope, like we also have in Scotland in many places. And you see that big boulder in the middle? It's like a meter-sized rock. It's quite a big rock.
Yeah.
And then we see that that rock...
Yeah, it's moved further down.
It moved further down.
On Earth, the same process, called a debris flow, is created when a landslide is so saturated with water that the loose rock and soil flow like a liquid. But Mars has very little water left, so what could be at work here? So have you got an idea?
So what we see on Mars, that Mars has seasons, just like on Earth. So in winter on Mars, it becomes so cold that the CO2 that is present in the very thin Martian atmosphere becomes frost on the surface. And then in spring, the planet heats up, and then this frost becomes gas again.
We're talking about sort of carbon dioxide, which is effectively dry ice.
Yes, it is.
So why does it differ on Mars than on Earth?
So on Mars, it forms naturally. It becomes so cold on the surface, minus 120 degrees Celsius, that it actually forms naturally. Whereas on Earth, we can only form it in industrial processes.
Yes, but the sublimation process happens here on Earth because you have dry ice and then there's no liquid, it just sort of vaporizes.
Exactly, so that happens on Mars as well. But the difference is that on Earth, when the CO2 ice becomes a gas, it expands a little bit, but the atmosphere is quite thick, so it pushes back on the gas. But on Mars, the atmosphere is very thin, so if it goes from an ice to a gas, it's much more explosive.
Yes, but a much bigger volume of gas,
yes, exactly.
Which can cause the flow.
Exactly.
Okay, so that is a nice theory, but have you got any evidence to support this theory?
Yeah, so we have remote sensing data that shows that the time of activity in these systems is the same as the moment in time in the Martian year when the CO2 ice sublimates. But that's only indirect, right? We don't have a rover there filming it, because you don't want your multi-million rover
just sitting there
end
watching.
up under this debris flow.
Oh yes.
So what I have done is I've recreated the Martian environment in the lab.
What does that involve?
Yeah, so this Mars chamber is an old diving chamber in which we can lower the atmospheric pressure to mimic the low atmospheric pressure that we have on Mars.
Yes.
And we can then make these debris flows driven by the sublimation of CO2 ice.
So did it work? What were the results?
It worked. It actually did work. So this CO2 can actually make this sandy material behave like a liquid. So that's really, really exciting.
But it must be wonderful for you because this is your research.
Yeah,
this is your theory.
Yeah, I was jumping up and down in the lab when this for the first time happened, of course.
Oh.
It's a new geologic process.
Geology always often feels as if we know it all. And so coming up with a whole new process must be exciting for you and your team.
Extremely exciting.
Fantastic. This new discovery has big implications, as it may suggest that there was less water on Mars in the past 5 billion years than was previously thought. While many mysteries still remain about Mars, for astrophotographers here on Earth, spending time observing the red planet can reveal some of its secrets. Pete is in Bletchley, taking us through his own mission to Mars.
I will admit I have found Mars frustrating over the years. I first saw Mars in the 70s through a homemade 222mm reflecting telescope, and I couldn't really see much detail on it at all. And I wondered what all the fuss was about. You get a good view of it for a few months around opposition when it's closest to the Earth, and then it takes 2.1 years before it gets to the next opposition. But as you do study it and you keep with it, you will notice that there is detail there, and those details get sharper and sharper. The first thing that became apparent was the bright polar cap. And then I could pick out the subtle markings on the surface, which are basically exposed rock. The rest of the surface, the sort of orange, pinky hues, are down to the sands of Mars, the deserts of Mars. It's a wonderful planet to measure your improvement in astronomy. So if you want to start your own Mars journey, here's how. Mars is an easy spot when it's in view and bright, thanks to its distinctive orange hue. And now is a good time to try and catch it before it gets compromised by the bright summer skies. To locate it in mid-May, just look to the western horizon, about a third of the way up from the horizon as the sky is getting dark. It then moves east, and by mid-June can be spotted next to the bright star Regulus. But the window to see Mars will be getting narrower all the time. Look for the pairing around 11:30 p.m, low above the western horizon. As Mars moves away from its opposition at the start of this year, telescopically seeing it at its best will need to wait until early 2027 as it approaches opposition again. But a naked eye spot of our red neighbour is always a beautiful sight. As we move into June, the nights get shorter and brighter, and that makes stargazing that bit harder to do. But it also brings the possibility of one of my favourite summer sights, noctilucent clouds, or NLCs. And if visible, these are typically seen from late May through to early August in the Northern Hemisphere. These high-altitude ice sheet clouds form in a narrow layer about 50 miles up, high enough to reflect the light from the sun after it has set. They appear to shine in the deep twilight, giving them their name, noctilucent meaning night shining. NLCs are easy to recognise because they're quite unlike regular clouds, glowing against the deep summer twilight. They typically show an electric blue colour and often have fine structures such as herringbone patterns. If regular clouds are present, these appear dark and silhouetted against NLCs because they're too low to be illuminated by the sun. NLCs can typically be seen somewhere across the northerly horizon depending on the time of day. Looking around 90 to 120 minutes after sunset, they can appear low above the northwest horizon, or a similar time before sunrise can find them low above the northeast horizon. A big display may persist all night long, moving from above the northwest horizon through north and ending low above the northeast horizon before dawn. Bright NLC displays can be so dramatic that they sometimes get incorrectly reported as the aurora. NLCs are a great target to capture with a phone, so if you're new to snapping the skies or a more advanced astro imager, do share any results you get with us on our Flickr account. And you can find details of this at bbc.co.uk/sky-at-night. Meanwhile, here are some images from the Milton Keynes Astronomical Society, as well as our Flickr account.
Since humanity first looked up at the night sky, we've been fascinated by Mars, that pale red dot in the night sky. But now, year by year, mission by mission, decade by decade, we're finally beginning to unravel its story, turning that pale red dot into a world. Good night.